Hi, I am Dr. K. Kannan, Professor in Mathematics, Hindustan College of Engineering and Technology. Video, I will be discuss about the method of variation of parameter for solving ordinary differential equations. This is a procedure to find out solutions of second order differential equation by using method of variation of parameter. Let us consider the second order differential equation is a0 d square y by dx square plus a1 dy by dx plus a2 into y equal to f of x, where a0, a1, a2 are constants. First step to find the complementary functions. To find the auxiliary equation, after that we solve the auxiliary equations, will be get the roots. Depending on the roots, to find the complementary function a into phi 1 of x plus b into phi 2 of x. In a second step to find w is also called Wrongian values. The Wrongian value is equal to determinant of phi 1, phi 2, phi 1 dash, phi 2 dash. Third step to find particular integral. Capital P into pi 1 plus q into phi 2, where P is minus integral phi 2 into right side of the given equation divided by w into dx, and q equal to integral phi 1 right side of the function divided by w into dx. Finally, the solutions of the given differential equation is y equal to complementary functions particular integral. For example, solve d square y by dx square plus a square into y equal to tan ax by using method of variation of parameters. We can consider the given differential equation is d square plus a square into y equal to tan ax. Now to find auxiliary equation, simply we replace d by m, the above given equation, m square plus a square equal to 0. We solve the equation m equal to plus or minus ai. Once the roots are real and imaginary, the complementary functions can be written as e power alpha x a cos beta x plus b into sin beta x. Here alpha is the real value, beta is for imaginary values. Simply we substitute the roots. The complementary function is a cos ax plus b sin ax. Find the Wrongian values. We can consider phi 1 is cos ax, phi 2 is sin ax from the complementary function. So the w equal to determinant of phi 1, phi 2, phi 1 dash, phi 2 dash. We can substitute these corresponding values and we take the determinant. The value of w equal to a. Now to find capital P, minus integral phi 2 into right side of the given equation divided by w into dx. We can substitute the corresponding value. So we get minus integral sin ax tan ax by a into dx. 1 by a is a constant, we can take outside, minus 1 by a sin ax tan expansion sin ax by cos ax. After that sin into sin is sin square ax. Here the denominator is cosine term, so that numerator is also we converted to in terms of cos. So sin square ax, we know that 1 minus cos square ax. After that we split this function 1 by cos ax minus cos square ax. Again 1 by x is secant ax minus cos square ax into dx. Now we can integrate, we will be get minus 1 by a square log of secant ax plus tan ax minus sin ax plus c. Now to find capital Q equal to integral phi of x into right side of the function divided by w into dx. We apply phi 1 is cos ax, right side of the function is tan ax divided by a. Expansion of tan is sin by cos, cos cancel, here the remaining sin ax. Integration of sin ax is minus cos ax by a. Finally, q is equal to minus 1 by a square into cos ax plus c. We know that the particular integral is p into phi 1 plus q into phi 2. Simply we substitute all the values, we can get the required solutions of particular integral. Finally, the solutions of the given ordinary differential equation is y is equal to complementary functions plus particular integral.